For the last lesson in our book, we're going to work with just a little bit more work with volume and density. So the opening exercise says the density of a American white oak tree is 752 kilograms per cubic meter. If the trunk of an American white oak tree has a circumference of 4.5 meters and a height of the trunk of 8 meters to the nearest kilogram, what is the mass? Well, I see the word density, so D equals M over V. Now, they told me that the density was 752. We're going to look for the mass, which means we have to find our volume. So the trees are cylinders, so pi r squared h. Now here's the key. The American white oak tree has a circumference of 4.5. So we know circumference is 2 pi r. So 4.5 equals 2 pi r. I'm going to divide everything by 2 pi. I'm just going to take a look at this for a second. So the first thing I want to do is I want to say that I want to do the 4.5 divided by 2 to get 2.25. And then I actually want to leave it as 2.25 over pi. All right, and you'll see why in a second. It's just going to be a lot neater as I put things into my calculator. So pi times 2.25 over pi squared times 8. So again, it's just going to be easier for me to put in my calculator. So pi times 2.25, and actually I'm going to use my fraction button here. This will make this even easier. 2.25 divided by pi squared times 8. And when I do that, I get 12.89155. So we'll go 12.8916. So V equals 12.8916. We'll take that, plug that in here. We know we're going to end up cross multiplying. So 1 times m is m. And then when I take that number and I multiply it by my 752, that gives me a mass of 9,694 and to the nearest kilogram here. So that's 9,694 kilograms. Okay, so some of the same process we've been working on some of our other problems. In example 1, a standard size golf ball has a diameter of 1.680 inches. The material used to make the golf ball weighs 0.6523 ounces per cubic inch. So whenever you have a weight per cubic something, and then they want to know what the weight is, that is a density question. So that weight per cubic inch is going to be our density. We are looking for the mass, and then they obviously want us to find the volume here. Well, a golf ball is a sphere, so 4/3 pi r cubed. Okay, so if we have a diameter of 1.680, if we divide that by 2, all right, we obviously don't really need the 0 at the end, but 1.68 divided by 2 gives us 0.84 as a radius. So we have a radius of 4/3 pi 0.84 cubed. Okay, now you could leave this in terms of pi. Something tells me when we cube the 0.84, we're going to end up with a fairly lengthy decimal anyway, so we might as well just put it all in the calculator together and take our 4 decimal places, and you get 2.4821. So V equals 2.4821. We'll plug that in here. Again, same as we've been doing, we'll cross multiply. And then when we take that number and multiply it by 0.6523, we get a weight of, and they want us to round to the nearest hundredth of an ounce, we get 1.62 ounces for our standard golf ball. In example 2, the streetlight question is probably one of the more challenging ones that they've ever asked. There's a lot of information in it. We have to kind of break things down. New streetlights will be installed along a section of a highway. The posts for the streetlights will be 7.5 meters tall and made of aluminum. The city can choose to buy posts shaped like cylinders or posts shaped like rectangular prisms. The cylinder posts have a hollow core with aluminum 2.5 inches or 2.5 centimeters thick and an outer diameter of 53.4 centimeters. The rectangular prism posts have a hollow core with aluminum 2.5 centimeters thick and a square base that is 40 centimeters on each side. The density of aluminum is 2.7 grams per cubic centimeter, and the cost of aluminum is 38 cents per kilogram. So notice, one of the first things I noticed right away, besides all the other information, is that the density is in grams and then the aluminum is in kilograms. So we're going to have to do a unit conversion at some point. If all posts must be the same shape, which post design will cost the town less? And then how much money? So this is a pretty extensive problem, okay? Let's work just on our cylinder posts first. So it tells us, so if we have our cylinder here, or whatever we're drawing as best we can as our cylinder, they told us that all of them are going to have a height of 7.5 meters, okay? Now, let's actually convert that, because if you see, everything else, including the density, is in centimeters. So let's just convert that right away to 750 centimeters. So this way we don't forget. All right, because everything else in the whole problem is in centimeters, so let's just make sure that that's in centimeters too. So 7.5 meters, 750 centimeters. Now here's the key. It says with an outer diameter of 53.4 centimeters. So that's across the whole thing. But it also says it has a hollow core. So the aluminum is 2.5 centimeters thick. So basically what's going to happen is we're going to have this center here that's cut out basically of our cylinder. All right, so it's going to be a cylinder that's missing its middle, okay? And the key is it is 2.5 centimeters thick, but that's 2.5 on each side, okay? So realistically, the overall difference in the diameter is going to be 5 centimeters difference. All right, that's what we're losing total out of it, okay? So that gives us an inner diameter of, well, what's 53.4 minus 5? 48.4. So that gives us a 48.4 centimeter inner diameter. So if we want to figure out how much aluminum is going to be used, we need to do the volume of the big cylinder minus the volume of the small cylinder, okay? So for any cylinder, we know our volume is pi r squared h. So if we do the volume of the big one, we get pi. Now if we take 53.4 and cut that in half, we get 26.7 squared times the height is 750. All right, and I'm going to leave this answer in terms of pi. So 750 times 26.7 squared gives me 534,667.5. So 534,000, erase this line, I'll redraw it over on the side. 534,667.5 pi. So that's going to be the volume of my big cylinder. So now let's see what's the volume of this small cylinder, the part that's missing, that's cut out. So if we take that 48.4 and we divide that by 2, we get 24.2 squared, and then times 750. So 24.2 squared times 750 gives us 439,230. 439,230, and again, that's still in terms of pi. So if we want to find out how much aluminum there is, we're going to subtract those two numbers. So 534,667.5 minus 439,230 gives us 95,437.5 pi. So 95,437.5 pi is our total volume of aluminum that's going to be different, or that's going to be used, I should say. Okay, so now we have to get into the more challenging piece that goes along this. Okay, so now we need to take that volume, 95,437.5 pi, and the first thing we're going to do is we're going to multiply that by our density. Okay, so we're basically going to figure out what is the weight of the aluminum in grams. Okay, so we're going to multiply that by our density to find our weight in grams. So when we multiply that by the 2.7, okay, and again, we're going to have to keep track of things a little bit in our decimal form here. So 2.7, and we can keep things in terms of pi if we would like. So let's do that. So when we get 257,681.25. So 257,681.25 pi. So now we are in grams. All right, so that's a good start there. So now what we want to do is we want to take that and we want to divide it by 1,000, and this is going to help put our weight into kilograms. Okay, so if we divide this by 1,000, we will then end up in kilograms. So 257.68125 pi. So 257.68125 pi. And again, now we're in kilograms, which is good. That's where we want to be. And then now we're going to multiply that by the 38 cents per kilogram that it costs. So 38 cents. And now we're going to have to put this into our calculator with our pi, because now we're at our last step here. So I'll multiply that answer by pi. We don't have to write that down. And then we will multiply it by 38 cents. And since we're talking about money, we are 307.62. So it's going to cost $307.62 to make these posts in a cylinder form. Okay, so that's definitely a lot of work. I get it. But it's all stuff that we just need to kind of work ourselves through very simply, and just kind of keep track of our work throughout the way. The next thing we're going to do is we're going to do our work for the prism. So the prism's kind of the same idea. It's got a square base, okay, and just like I can't really draw them vertically, so I'll draw it horizontally. So it's also going to have a section of it cut out. All right, so it's also going to be missing the section. So it's the same 750 centimeters as our height, okay? Because just like the cylinders, it said it was 7.5 meters, so we're really 750 centimeters. Now, what else did it say? So it's also 2.5 thick on all sides, So 2.5, 2.5, 2.5, and so on, okay? So it's got a original or an outside distance of 40. So what we're going to do is we're going to calculate the volume of the big cylinder, then we'll calculate the volume of the missing smaller one, and we'll subtract and do all the same multiplication basically that we just did. So the big one is 40 times 40 times 750, because we know the volume of a prism is capital BH. In this case, these are both square or rectangular, so length times width times height. So we are 40 times 40 times 750. So as we do that, calculator, 40 times 40 times 750 gives us 1,200,000 as the volume of our big one. So 1,200,000. So now we'll do the volume of our small one, and here's where we got to be careful. So we're losing 2.5 on each side, so that really makes the inner 35, but then we're also losing 2.5 and 2.5 vertically. So really it becomes 35 times 35 times 750. So 35 times 35 times 750, because both the length and the width here are losing 5 centimeters off of each side. So 35 times 35 times 750 gives us 918,750. So 918,750. So now I'm going to subtract those two numbers. I think I have too many zeros there. That's good. So then I subtract them. And that gives me a total aluminum volume of 281,250. So 281,250. Okay. And again, this volume is now in grams per cubic centimeter. So we're going to do the same thing that we did before. So 281,250. We'll multiply it by the 2.7, and that will give us our weight in grams. So if we multiply that number by 2.7, that gives us a weight of 759,375. So 759,375 grams. Just like we did before, we'll divide it by 1,000 to put it into kilograms. Okay, and I'm just doing this in the calculator to kind of keep my numbers with me so that I can just multiply. So 759.375 kilograms. And then, in order to get the cost, we are going to be times 0.38. So multiply by 38 cents, or 0.38. 0.38 would be helpful. We get $288.56. So $288.56. So we do want to make sure we are answering the question, right? Which one is going to cost the town less? The prism cost less. Now it also says by how much? Well, 307.62 minus 288.56. And when we do that, we end up with a difference in cost of $19.06. So the prism costs less, by 1906. All right. So again, we're just going to kind of keep track of everything. Trying to figure out the dimensions of each of the shapes is probably the hardest part, but it is something that is definitely doable for you guys. As we move on to the last one, which is about the kickboxing class. In example 3, Shane has recently begun kickboxing and purchased training equipment as modeled in the diagram below. The total weight of the bag, pole, and unfilled base is 270 pounds. So we're going to end up kind of holding on to that at the end a little bit. The cylinder base is 18 inches tall with a diameter of 20 inches, and dry sand is used to fill the base that weighs 95.46 pounds per cubic foot. So here's the thing. If that density there is in cubic feet, I'm going to want to change these already. So 18 inches is really 1.5 feet. And then I know the diameter is 20, but really that means our radius is 10. And then if we were to convert that to feet, you could leave it as a decimal, but really 10 inches out of 12 feet is really 5/6. And I think leaving it as 5/6 is going to really help us here as we don't have to carry around irrational decimals, or repeating decimals, I should say. So determine to the nearest pound the total weight of the training equipment if the base is filled to 85% of its capacity. Okay, so first things first, let's find the volume of the base. So the volume of the base is a cylinder, so pi r squared h. So pi r is 5/6 squared, and our height is 1.5 when we are in feet. So I'm going to leave this in terms of pi in the very beginning. So 5/6 squared times 1.5 gives you that. Let's see if we can convert that into a decimal. I get 25/24 pi. So that gives us 25/24 pi. Now again, you could just figure out what your decimal is, go 4 decimal places, and you should be fine. But if I can make it into a fraction, I just feel like it makes my life a lot easier. So now that we have found the volume of our base, let's use our density formula. So density equals mass over volume. So they told us the density was 95.46. We're looking for how much it weighs. And then we just found our volume to be 25/24 pi. Okay. So now we're going to put this over 1, cross multiply, and find out exactly how much a full base weighs. So 95.46 times 25/24 pi gives us 312.3921. So 312.3921. So remember, that's 100% full. That's how much it weighs. But they only want 85%. So let's multiply that by 0.85. So times 0.85, not 82, 85, gives us 265.5333. So 5333? So that right there is 85% full. Now remember, that right there is just the base. They told us in the very beginning, when the base is empty, that this weighs 270 pounds. So if we want the total weight now, we have to take that number and add the original weight before any sand was added. So plus 270 gives us 535.5, and it says to the nearest pound. So therefore we are going to be 536 pounds as our total weight. So again, what we want to do is we do our unit conversion in the beginning. We find out how much the base weighs full. Then we figure out how much it weighs at 85%, and then we add that to the original empty weight to get our total weight at 85%.